Hello, and welcome everyone to today's webinar, Building a Real Chatbot with Oracle Database 23 AI. My name is Nikki, and I am a marketing event manager for the developer initiative here at Oracle. And today we're excited to walk you through how to build a chatbot designed to interact seamlessly with Oracle Database documentation. This session is being recorded, and we'll be sending the session recording to the same email address used for today's event in the next few days. If you have any questions during the webinar, please drop them in the Q&A area and we'll be happy to answer those questions for you. We have also set up a Slack channel, Cloud Coaching North America, in our developer workspace that you can access at the QR code or the link on the screen. This channel remains open after the event for you to contact us directly whenever you have any questions. And today's webinar will be presented by three amazing speakers, Mark, John, and Corrado. Without further ado, I'll pass it to Mark.
Thank you and welcome. Well, it seems like everyone is talking about chatbots and AI these days, but what makes a chatbot good enough to let it represent your company? Before we answer that question, let's quickly introduce or review the important concepts and challenges. Then we'll spend most of our time with live demos, learning how to iteratively improve accuracy and quality, and how to automate evaluation to detect issues. Remember, if you have questions, please ask them in the Q&A. Generative AI is a type of AI that uses language models that have been pre-trained on a large amount of knowledge to create new original content in response to a user's prompt. They are often used to power chatbots and have a conversational interface. Retrieval Augmented Generation, or RAG, is a technique very commonly used with generative AI to provide extra information to the language model, information that it has not seen during its training. Often, this will be information that is not public or is domain-specific, or just information about things that happened after the model was trained. The model uses this extra information to answer questions posed to it by users. Here's how it works. The user's question is turned into a vector. A vector database is used to find content that is closely related to the question. This content is provided to the model to help answer the question. The model can use its existing knowledge plus this extra information to provide an informed answer. Let's talk a little more about vector databases. This extra information is called a corpus. We start by breaking it down into chunks. Then we create a vector representation of each chunk. We store these vectors in the vector database. The vector database can perform semantic searches to find other vectors that are similar to a given vector. A vector is a sequence of numbers called dimensions. Each dimension measures some quality of the information. Here is a dramatically simplified example where we have two dimensions, largeness and dogness. St. Bernards and German Shepherds are both large dogs, so you see that their vectors are very similar. A wolf is large, but it is not a dog. But wolves are a lot like dogs, so its vector is high on largeness, but lower on dogness. A tennis ball is not large or a dog, so its vector is very different. In reality, there are many more dimensions in vectors. Commonly used models today range from a few hundred to several thousand dimensions, and the qualities measured by dimensions are not so clear-cut. They tend to be abstract and may not even relate to a concept that we might use to describe a thing. There are different ways to measure how similar two vectors are, but for text, the best option is called cosine distance, which compares only the direction of the vector, not the length. Oracle Database 23 AI is a great vector database. It uses sophisticated index to dramatically accelerate vector searches. It transparently scales across nodes in a RAC cluster. It can also dedicate vector processing to a subset of nodes to avoid impacting other workload. And it can offload vector search to Exadata smart storage. Vector processing can also be sharded across geographically distributed databases for a huge scale or data sovereignty concerns. So let's talk about the fallacy of the quick chatbot. There are a lot of articles and videos that claim to show you how to build a chatbot very quickly, but none of these are production quality. Why not? I'm sure you've heard stories like this one about chatbots making embarrassing or even harmful mistakes. No one wants to be subject to that kind of ridicule in public. And that's why it's so important to understand what is involved creating a real chatbot. Some common challenges are choosing the right AI language model, understanding the context window size, the quality of the corpus, the question and the prompt, and dealing with information that the model does not know about. Some aspects of working with language models can be extremely expensive, both in terms of time and money, so it is important to get it right. Models also have a tendency to make up answers if they don't have the necessary information to answer correctly. AI folks call this hallucination. So how do we address these issues? There is a lot of research in industry and academia, and there are many promising emerging techniques. This space is evolving all the time. Let's drill into some of these success factors. Models are trained on different sets of knowledge and for different purposes. Some are optimized for embedding, or inferencing, or summarization, and some are general purpose and can perform different tasks. It's important to choose models that are good at the task you need them to perform. Chunking is harder than you'd expect. Consider this chunk of a PDF document. It spans different topics. It has headers and footers mixed into the text. It missed parts of the first and last sentences, and it's very likely has no information at all from the images. Compare that to a structured chunking approach. Here, we take only a single topic, and we retain knowledge of the hierarchical structure of the content. We also avoid including extra unrelated text. In the demo, you'll see how much chunking can affect the quality of the output. A new technique called sentence window retrieval improves vector search results by creating embeddings at the sentence level, but the whole context is provided to the model, not just the one sentence. The context window is a really important concept to understand. It's basically everything that the model can see. It has to hold not just the question from the user, but also the system instructions, which tell it what to do, the chat memory, the agent work area if agents are being used, all of the chunks retrieved from the vector database, and also the answer. Here's an example of a prompt. Each model expects its prompt to be in a certain format. The prompt gives the model extra information about the task it has to perform. And prompts also have a major impact on the quality of the results. Optimizing the prompt is a whole field in its own right, called prompt engineering, and a lot of effort can go into this work. Each model has parameters that affect the response it creates. Some important ones are temperature, which controls how creative the model is. Several parameters control which candidate tokens or words are considered when choosing the next token in the response. And maximum tokens controls how long the response can be, and therefore how verbose or terse the model needs to be. So what can we do to minimize the downsides and build the best possible chatbot? The single most important success factor is experimentation and iteration. This is what will separate the winners from the losers: the ability to experiment with all of the variables and measure the results. Oracle AI Playground lets you use any data, any embedding, and any LLM. John is going to show it to us now.
Thanks, Mark. Now let's see some of those topics in action. We're going to build a chatbot from the ground up, starting with that quick chatbot Mark mentioned and ending with a full-featured RAG-enabled chatbot playground. We'll use Python in this demo, though other programming languages are available. In fact, some of my colleagues have published examples in Java, JavaScript, and Spring. We'll also introduce a framework. Now, frameworks aren't essential to build a chatbot, but they do help with some of the more tedious tasks, as I'll point out in the demo. We'll use LangChain as it helps us link, or rather chain, our LLM to our Oracle database vector store to our GUI, but other frameworks are available. For the GUI, we've chosen Streamlit as it's popular with data scientists and easy to develop with. And last but not least, we'll use the Oracle database 23AI as our RAG vector store. So in order to demonstrate the effectiveness of our enhancements along the way, we're going to play a little game with a twist of Jeopardy! In this game, our question to the answer is always correct. It's just that the chatbot might not know it yet. And as a disclaimer, if you're watching this on sorry, that might not translate out of the UK. If you're watching a rerun of this, language models move fast, and they may be trained on the Oracle AI Vector Search User's Guide tomorrow, which will render our game obsolete. But the idea remains the same, especially when it comes to your private data. So, without further ado, let's start our demo. Here I've written our quick chatbot in Python. If you're proficient in Python, something like this will take you probably around 5 minutes. But if not, just ask one of the existing chatbots to write it for you. We're going to use OpenAI language model. So we need to import the Python module. We'll need to have and set our OpenAI API key. And finally, we'll need to establish a client connection with OpenAI. When we start our chatbot, it's going to run in an endless loop. It's going to accept user input, calling the getOpenAI response function with the input, and output the response until we either type by or exit. Now, the getOpenAI response function does most of the work. It interacts with the language model by sending it our input along with the system prompt that sets the context. And in our case, the context instructs the LLM that it should behave as a helpful assistant and personalize the response if it can. We'll create a list of dictionaries in the messages variable, where each dictionary represents a message in our conversation. Finally, the function makes the API call to generate a response. We'll extract the relevant part of the response and return it. For now, we'll use the ChatGPT 3.5 Turbo model for generating the completion. Pretty easy, right? So let's see it in action. I'll start a QuickBot, and I'm going to give it my name and ask a non-specific question about how I determine the accuracy of my vector indexes. Now, as I would expect, I get a fairly generic answer. So I'm going to focus it on the Oracle database 23AI. And here's where things get fun. The model we're using, GPT 3.5 Turbo, was trained well before 23AI was available. In fact, the last version it knows about is 19C. It also seems to have completely ignored that I wanted to know about vector indexes. So let's rephrase our two questions into one. And now we have a hallucination. Despite, based on its previous response, that it knows nothing of 23AI, it comes up with an answer about DBMS data mining in 23AI. And while that package exists, the procedure it recommends, detect index, certainly doesn't. So since it seems so sure, let's ask it for a little bit more information. And of course, it seems to have no idea what we're talking about. Finally, it never used my name other than in the first response. So let's ask it why. And it's because it doesn't know it. Well, that QuickBot failed spectacularly, and we can attribute this to a few things. Two being using an LLM not trained with recent data, and no concept of history or context. So let's warm it up a little bit. Now in our new enhancement, our main loop remains the same, but I'm going to change up the get OpenAPI response to implement history. Now I could create my own Python list and append each user input and response to it, and then take that list and inject it into the message for the LLM. But instead, I'm going to introduce a framework to handle the history for us, and here's why. As Mark mentioned, LLMs have a context window, and chat history is included in that window. So if I create my Python list, I also have to maintain it. I have to trim it when it gets too large, maybe summarize it so that I don't lose too much context on a trim, or maybe I want to persist it in a data store. Most good frameworks will have written all of that for you. So I'll take advantage of that existing code. And in this case, I'm going to use the framework functionality to store the history into memory. To do that, I need to import the framework modules, in this case, LangChain. And I'm going to change the OpenAI model to GPT-4o Mini, which is newer than GPT 3.5 Turbo, so it might know about 23 AI. I'll leave the system prompt the same for now, and use a chat template to start building our message chain. The template is useful for those instances where I don't have any chat history. The framework will take care to ensure my message is still formatted properly. We'll start the chain and pass it to our runnable, which will format our message by injecting the variables and also take care of updating our in-memory history. Finally, we'll invoke the chain, sending it to the LLM for a response. So, with history implemented, let's spin up this improved chatbot. I'm going to go through the exact same questions as before, but with our new model and history in place. How do I determine the accuracy of my vector indexes? Now, quite a bit more information is in the response, but again, it's too generic for my purposes, so let's focus it in on 23 AI. Now, the first thing to keep an eye out for is if it understands that the it in my question refers to vector indexes. The response definitely has a lot more information than the previous model, but it's correcting me that the version is 23C, also known as 23C AI, so its training is still a little bit out of date. It does make reference to the vector index, so it's used the history to establish context around the word it, showing me we've implemented the history properly. Now, to be consistent, I'm going to give it our win around question, though I suspect its response, due to history and context, will be very similar. And it is similarly complicated, and only slightly different. I'll attribute that to not setting any sort of temperature parameters, giving it some freedom to be creative. And finally, why didn't it use my name? Well, I can't explain that, but at least it remembers it. We've made some progress. We've implemented history using a framework that will help us maintain it as we improve our chatbot. And we're using a model that at least knows about a version 23 of the Oracle database, though that didn't really seem to help us getting any closer to the answer we were looking for. But at least it wasn't inventing stored procedures. Well, not yet anyway. We'll need to do some tweaking to get our answer. But if we want to make this a real chatbot playground, we need to give it a GUI. In our GUI bot, the get OpenAI response remains the exact same, but we're going to change the main function and introduce the GUI functionality. The concept in the main program remains the same though. Prompt for user input, ask the LLM for a response, print the response. Now the GUI is going to behave differently than our command line program, in that it's going to refresh and rerun all the code every time. So if we want to see our history, we need to regurgitate it every time. And really, those are the only big changes in this next iteration. We're going to use Streamlit for the GUI, so we'll import the modules. We need to ensure that our in-memory chat history is persisted in Streamlit session state, so we don't lose it on each application reload. And Streamlit will use that session state in our main program to produce a nice looking chat interface. Finally, let's start passing the LLM some parameters. We're going to change the temperature to 0.5 and see what sort of impact that has on the model's response. Right, so I think we're ready to start our GUI chatbot up. We'll use the Streamlit binary instead of Python to run it. Once I start it, it's going to listen onto a localhost port that we could connect to with our web browser. So let's get this started. And we'll open our browser. Right. So this time we're going to cut straight to the chase and ask it our round-winning question. And while we're using the same GPT-4o mini model as before, we have reduced the temperature this time. So let's see what sort of response that gives us. And it looks like that's made quite a bit of a difference. Let's take a closer look. So first we see it's acknowledging a 23AI version, but it's gone completely off the rails and made up a stored procedure. By reducing the temperature, it has given the model a bit more confidence, and as a result has hallucinated with what looks like, to me anyway, a pretty high degree of certainty. I mean, that response looks plausible and close to the answer we want. It's just a shame that the procedure doesn't exist. So there's a lot more tweaking to be done, and now that we've got the code and the framework foundations in place and a GUI on top of it all, let's fast forward where we can start making quick changes and utilize RAG to get at our answer. I'm going to switch screens to our fully implemented Chatbot playground. This is where we can make changes directly in the GUI. We've added some sliders and select boxes to be able to tweak the model's parameters. We've also added a few LLM models to choose from. We'll try Llama 3, and when I select it, the parameters will change to its defaults, which are less creative than OpenAI. But before we ask our question, I'll say something about data sovereignty. So far, we've been using publicly provided models. But if I'm asking about private, sensitive data, maybe I should be asking for it on an on-premise model. So we've added a feature where if you want to run an embedding server or an OpenLLM, such as Ollama on-prem, you can configure it in the GUI. Right. So back to our chatbot. And we're going to ask Llama 3 about how to determine the accuracy of my vector indexes in Oracle Database 23AI. And it's come back with something that looks somewhat plausible, but let's check it out. So it's suggested DBMS data mining, which is a package that does exist. But it's also said that the procedure is evaluate model. And if we look for that, nope, not in the documentation. So it's definitely hallucinating. Let's decrease the top P so that it's less creative and a bit more deterministic. And we'll go ahead and ask the same question again. And now it's apologizing for its earlier mistake because 23AI does not support vector indexes. So it's traded one fallacy for another fallacy, and it's given us some sort of alternatives to determine the accuracy of our indexes that don't exist in 23AI. Well, let's clear our history, and we'll ask GPT-4o mini again. Let's see what it says now. And something slightly different, but not too far off. At least it's not making up the stored procedure again. But this essentially establishes our baseline. But it's not the answer we're looking for. And let's just prod it to see what happens if we ask for an example. And it's come up with some sort of random query. So let's get down to RAG business. We're going to need a database for the vector storage, and I've gone for the Oracle Autonomous Database 23AI. Now let's split and embed. Again, this is another component where, depending on how private your data is, you may want to consider doing it on-premise. I'm going to switch to the Text Embedding 3 small model. And I'll keep the chunk size and overlap to their defaults for now. And I'll also keep the distant metrics to cosine. I'm going to use the Oracle AI Vector Search User's Guide PDF from my local machine. And you'll see it's determined that the table name based on my settings, where it's going to store the chunks and vectors. And before I load it, let's just check that that table doesn't exist. Nothing. So let's go ahead and create and populate that table. We'll go back to our database. And there it is. There's our table name. Let's just take a quick look at the data. So there's my text chunks. We can probably do a max length on that column and we'll never see anything more than 8191. And there's our vectors. And just out of curiosity, let's see how many rows are in this table. Looks like 231. Okay. Let's do the same process again, but we're going to change to a chunk size of 256, and you can see that it's established a new table. We're going to load that in. So we're populating the vector store again. And we're being patient. And let's go check our database. There is the 256 chunk size, vector storage. And again, we'll take a quick look at the data. And you'll notice that the text size is significantly smaller than the chunks from the 8191 chunk size. And if we look at how many rows, definitely expecting more than 231, and sure enough. Now, because we're switching to RAG, we're going to need a new prompt. So before we were just saying be helpful, but now we're going to ask the LLM to use the retrieve documents. And if you don't know the answer, just say you don't have enough information to implement it. We're also going to send it some contextualized instructions. And that's just to help it when I say things like it, to look at the history and reformat my question so that it's a little bit more useful. So let's turn on RAG and disable re-ranking. Now I could change the search type, but I'm just going to leave it to similarity. And yeah, if I were to change it to marginal maximum relevance, I've got a bit more option, but let's flip it back. Good. And we're going to choose our chunk size, and it's only going to show options of the embeddings that I currently have in the database. And let's ask it our question again. We're going to clear its history so it doesn't use the bad information that I had before. And there we go. We have the answer we were looking for. DBMS vector index accuracy query. And we've got references to where it found it in the documentation. But let's go for the bonus question and ask if it can give us an example of how to use it. And based off our prompt, it's come back and apologized. It says it doesn't have enough information, but that information is definitely in the documentation. So the chunk size has had an impact on what it knows and what it can bring back. So let's switch it to the larger chunk size. And we'll ask it once more whether or not they can give us an example of using index accuracy query. Now, because I have history and context, I could say example of using it, and it should come back okay, but we'll be specific. And there we go. It's pulled out from the documentation an example of running the package and procedure. And if we check the references, because our chunk sizes are much larger, it has much more to work with and much more to return. I'm quickly highlighting the chunk indexes there at the top to kind of give you an idea about what re-ranking does. So at first it found chunk 182 as being the best chunk, 181 following that, and 183 as the last useful chunk to give us this information. And I've turned on re-ranking, and just keep in mind I'm re-ranking on my local PC, so it's not exactly the quickest re-rank. But if we look at the chunk index again, it's kept 182 at the top, but it's gone and it's switched 183 and 181 around because it's now, after the re-ranking, found that 183 is a more useful document than 181 in terms of determining the answer. So let's close the loop here. We've asked 4.0 Mini whether it knew it, and it did after the RAG. And now let's ask 3.5 Turbo, which we used at the very, very beginning of the demonstration. And there you go. It also understands and gives us the correct answer. And finally, we'll go back to Llama 3, which we started with in the GUI. And we'll clear history just to make sure that it's not going to reuse anything it knew before. And we're going to open up max tokens so that it can free flow the answer. Not only did it give us the right answer, it gave us the bonus answer as well. And it picked up a different chunk as its top reference. So it looks like there's still a little bit more evaluation to do. And while doing all this manually can be good fun, Corrado's going to talk about how to implement a testing framework around it to speed up the process of prototyping to production.
Okay. John has tested only a few questions with a RAG configured with two set of parameters. And it seems performing well on the largest chunk size. But I'm sure that John is still not confident that on a 200 pages document, the RAG will be able to answer correctly on any topics included into this doc. In any machine learning project, you need a training and test dataset like this, but usually the test dataset must be around 20% of samples or extracted randomly from the original dataset. In this case, we don't need the training set, but definitely we need the test dataset that we haven't. We have only the original document used to populate the knowledge base into the vector store. From the other side, creating a consistent test dataset requires normally a huge effort, especially when at the beginning you don't have any human feedback on the answers provided by the chatbot that you can eventually collect to create a test dataset. So how we can mitigate John's concern without spend time and money in a test dataset creation? Through the test page that we have included into this platform. How it works, on the current configuration we have tested in Playground, you can perform a massive automated test that provides to you an overall accuracy or correctness using a technique called LLM as a judge approach. In other words, using another LLM to generate Q&A on a set of chunks created starting from the main document, and another LLM to compare the Q&A with the reference answers generated at the previous step. There are several other techniques to perform a RAG evaluation, but normally you need a test dataset to analyze with some metrics like BERT score or distance metric. But let's start with the demo. I have already two vector stores tables created as shown by John with the same embedding and chunking sides, two chunk sides and same embedding model. First of all, we have to freeze the configuration knowledge base we are going to test, setting the parameters and ask something to the chatbot in order to verify that everything is correctly defined. So let me ask exactly what John has already used in his playground to see what happened. So now we can move to the test page because we have the environment ready to be tested. The test page reports, first of all, the frozen configuration to be tested. To be totally independent from knowledge base and any bias coming from the vector store uploaded, the test procedure starts from the original independent document. The document will be split in chunks, but with a different aim. Create a set of text on which generate Q&A. So we upload this document, and let's start with a small synthetic dataset of 3 Q&A only, the RAG evaluation. So the first step is to create the test dataset that will come in a few seconds. This is a real-time registration, so for 3, this is the time that they have to wait. Because we are getting topics from the document, chunking, and ask for a Q&A example. So this is the list of questions and reference answer provided for each topic, the reference context, the piece of document on which have been created the Q&A that is included here, the conversation history if you want, and the kind of document in the metadata, a simple question, and the topic on which is based this question. As you can see, at the bottom has arrived the RAG evaluation. That is quite low, as supposed by John, because we have only one question correct. This is the overall correct score is quite easy to understand. It's simply the number of correct question divided by the total number of questions. As you can see here, you can see not only the original data, but the agent answer that provides less information that needed into the ground. And this is the reason why provided by the LLM, why is not considered good this question. So you also have a feedback by the LLM that has analyzed this Q&A. At the bottom, you will find the list of Q&A that have been submitted to test, with the only one that has been considered correct. So we have to iterate again. So let's start again the model, but now choosing a different chunk size. First of all, we reset the environment. We choose and chunk size the largest one, the related overlap. And then we can proceed to the test, asking for a question, first of all, that frees the environment. And then we can wait for the answer and move to the test to verify what's happened on free question again. So in the test page, first of all, you can recheck if everything is good. Why? Because each running costs, because you are asking evaluation to service provided externally. Again, we provide the same document, and we ask for 3 questions to be generated. In this case, we leverage on the same questions generated before in order to have a comparable baseline on which compare the 2 configurations. Otherwise, with a different test dataset, you not meaningful the answer. So after the evaluation, we will have the final score that is coming. This is a real-time registration. And we will see that we have a confirmation that the largest chunk size is better, but we are talking about only 3 questions. But it's a preliminary step to understand how it's working with the few questions that we have generated automatically. We still have failures that avoid us to have the 100%. Now let's go on massive data test data set, resetting the environment on the 256. Why? Because it's not sure that with the small we can get a better results, because now we are going to test on more questions provided by the system. Again, we freeze the environment. And after receive the answer, we can go to the massive test dataset. In this case, we are setting 15 questions to be generated, but it takes time. So in the video is compressed, and we will see immediately the answer coming from the RAG evaluation. We have a better results compared to before, but we still have to check if it's better to work on the 8,000 chunk size. So we return to the environment, the playground. So as you can see, it's an iterative task also for the evaluation. Now we are going to choose probably the better configuration. And we are going to check if also in a huge number of questions, this configuration is good to be candidate to a production deployment. Okay, now we can again choose the file. If the system find the same configuration, the same files, we provide what is in cache, as in this case. So we haven't to wait, and we can see that also on more question, the results are better. There are still some failures. We haven't reached the 100%. So let's investigate why. We can see that the original question, the reference answer created into the synthetic dataset is this, very synthetic. But the agent answer is verbose and not include what is asking for the question and the related correct reason. This is the reason explained. But even if the synthetic dataset could be considered good, even LLM, synthetic dataset generation and evaluation, is subject to hallucination because come from an LLM. To produce raw Q&A to be verified, it's much better. In any case, in terms of effort and cost, than preparing from scratch a bunch of Q&A. So in the future release, probably we include also the possibility to modify the Q&A dataset and also the evaluation, because at the end of the day, the human feedback has still the last word, so you can recalculate the overall correctness. As I've shown, the process requires a lot of iteration, and the aim of this platform is to simplify without coding the execution of pipeline. Since the few lines of codes to write the chatbot, leveraging GenAI frameworks, it's only a minority part of the effort to put in production an enterprise chatbot based on GenAI. Indeed, the test phase is much longer than the code setup part. So we want to address this issue with the freedom to use any data, any embedding, and any LLMs.
Today, you've seen the Oracle AI playground, which is under heavy development right now and a developer release will be coming soon. If you'd like to be notified when it is available, please send us your email address in the webinar chat. We've been looking at a chatbot using RAG, but the AI Playground will also support other use cases. We're actively looking for people to try it out and give feedback to help us build the ultimate tool to create enterprise-quality, production-ready chatbots. Thanks for joining us today.